Welcome. It's another episode with Chemistry Simplified with Rosalie. In today's lesson, we are going to be looking at the structure of an atom. What exactly is an atom? An atom is the smallest elementary particle of an element. An atom is the smallest fundamental particle of an element that can take part in a chemical reaction. John Dalton, in one of his postulates, stated that atoms are indivisible, but today we know that that is not quite true. Atoms can be subdivided into protons, electrons, and neutrons. Atoms also consist of a center part. We call that part the nucleus. That's where the mass of the atom is concentrated. Now, let's talk about the protons. The protons are positively charged and they are found in the nucleus of an atom. Like we said, they are found at the center because the nucleus is found at the center of an atom. Protons are found at the center of that atom and they are positively charged. Protons are responsible for the atomic mass of an atom, for the atomic mass of an atom. Also, we talk about the neutrons. The neutrons are neutral, meaning they don't have any charge. Their charge is 0. And the neutrons too, they are responsible for the atomic mass of the atom. Now, let's go to the electrons. Electrons are found around revolves around the nucleus in paths called shells or orbits. We should also note that in an atom, there might not be only a single shell. We might have 1, 2, 3, or even 4 shells, depending on the number of electrons that atom has. It's also worth noting that the number of protons in an atom is equal to the atomic mass of that atom. For instance, let's take sodium. Sodium has 11 protons, meaning the atomic mass of sodium is 11. Now, let's illustrate an atom of the bomb. We said an atom consists of a central nucleus. Let's take for instance, this is our atom. This is the nucleus of an atom. Now, inside the nucleus, we said there are found protons. Let's say this is the nucleus of an atom. Inside the nucleus, we said there are found protons. Let's represent our protons with P, and neutrons. Let's represent our neutron with letter N. We should also note that in an atom, the number of protons is also equal to the number of electrons, as we are going to see further. Now, this is our nucleus. Since these protons are positively charged, we write our positive sign beside them, and since the neutrons they are negatively charged, we write our negative sign. And since the neutrons are neutral, we represent them with small zeros, meaning they don't have a charge. Since the protons are positively charged and the neutrons are neutral, this means that the overall charge of the nucleus is positive. The nucleus takes the charge of the protons. Since neutrons, they don't have any charge. We also said that the nucleus is surrounded by shells. By circular paths, we call them shells or orbits, and that is where the electrons are found. For instance, let's take an example of sodium. In our previous videos, we said sodium is found in period 3, meaning sodium has 3 shells. Let's take, for instance, sodium with 3 shells. We are drawing our shells. Shell 1, shell 2, and shell 3. Let's take for instance, we are working with sodium. We said the electrons move around in circular paths called orbits. These are our orbits or our shells. And we also know that these shells, they are placed according to their energy level. The shell closest to the nucleus have the least energy, and as we move away from the nucleus, that's how the energy level increases. Let's take for instance the first shell. Let's just number the second and the third shell. Now, let's place our electron. We said the atomic number is equal to the number of protons. Like we know, sodium has 11 protons, meaning the atomic number is 11. Now, let's place our electrons. We have the first shell takes a maximum of 2 electrons. 1, 2. The second, a maximum of 8. 1, 2, 3, 4, 5, 6, 7, 8, and the third takes a maximum of 18 electrons. But since we are left with just 2, we put our 2 electrons. And if we count together, since sodium has 11 electrons, we have placed 2, 8, that is 10. Just a single electron is remaining. We put it here. So this one is the simple structure of an atom of sodium. It's good that we should also note that the electrons, they are negatively charged. They have a charge of negative 1. They are negatively charged. Let's attach our negative sign, meaning an atom is electrically neutral. We have positive charge here and we have negative charge here. We should also note that in an atom, the number of protons should be equal to the number of electrons to give an atom a neutral stability, to make sure that an atom is neutral. And that stability comes from the number of protons and the number of electrons that are equal. I'm going to give you an acronym in which you can easily remember which one is equal to which. Let's take for instance a pen. Let's write a pen. We're having a pen. And then we write our equal to in between A and P. We write our equal to in between P and E. We still write our equal to. And in between E and N, we write equal to and not equal to. Now, let me explain. A stands for atomic number, meaning atomic number in an atom is the same like the number of protons. And number of protons is still the same like number of electrons. But at times, all of these are equal. All of this is still equal to the number of neutrons, and at times it is not the same. Why? Because of the existence of isotopes. Let's take for example sodium. The atomic number of sodium is 11. So the number of protons in sodium should be 11 as well, and the number of electrons should be 11 as well. But the number of neutrons might be 11 as well as it might not be equal to 11. So we need to calculate to make sure that the number of neutrons apply here. But how do we calculate? It's good that we watch our next video to see how to calculate the number of neutrons.